Today we're going to be going over the Java solution for Leetcode 35. Search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it was inserted in order. You must write an algorithm in O of log n runtime complexity. Okay, so let's look at examples to see what they mean. So we're going to give it a list of, or an array of integers and a target. We're trying to find 5 in it. And so we're just going to look through it and we see, there is a 5. And we're going to return its index, which in this case is 2. With example 2 here, we're looking for a 2. We don't see it at all. But it also tells us that if we don't find it, return the index where it would be if it was inserted into this array following the sorted pattern. So if it was sorted and we were to insert a 2, it would come right after the 1 and before the 3, so its index would be 1, and that's what we output there. And then now here our target is 7, so we're going to be looking through it. We don't see it, and in fact 7 is the greatest element, so it's going to lie after 6. So 6 is the third index, so 7 is going to be the fourth index if we were to insert it. So yeah, this is a pretty simple one. If you know binary search, then you basically know everything you need to solve this problem. Some key hints to know that's binary search is that number one, you're given a sorted array, so that's big hint number one, and number two, you're asked to do it in log and runtime complexity, which is exactly what binary search is for. So if we're gonna do binary search, let's have our 2 pointers. So int I is equal to 0 and int j is going to equal nums.length minus 1, so the very ends of it. And then while I is less than j, we're going to make our mid, which is going to be I plus j minus I divided by 2, which is just the middle point. Instead of doing I plus j divided by 2, this means the exact same thing, but it avoids integer overflow in Java. And now we're going to say if nums of mid is equal to the target, then we found it, so we could just return the index, which is mid. Else if nums of mid is greater than the target, then that means we know that we overshot, we highballed. So we're gonna turn j into mid, and then else we know we lowballed if nums of mid is less than the target, so then we could set I to be mid plus 1. And then at the end of it all, if we don't find it, so if this isn't triggered, then that means that we're gonna have to figure out where it's gonna be inserted, and it's gonna be at I. So this is gonna keep narrowing it down closer and closer and closer, down, 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 until even though we can't find it, it'll still try to close it down. And we know it's gonna break the loop with the while I is less than j, and then at the end of it all, I is going to be that index. So if we're like, for example, with this one right here, if we were to go through a simulated version of that, we have I and j right here. The middle of that would be 1.5, or it would get trounced to 1. So we're looking at this 3 right here. Now we see that the 3 is greater than our target, so that means we're going to decrease our j. So now j is now this index 1 right here. So we have I being 1 and then j being 3. Now the middle of that's going to turn out to be 1, and we're going to see, and we see that it is greater than the target. So then I is going to increment to be 3 right here, so mid plus 1. And then here the while loop is going to be broken since I is no longer less than j, it is equal to j. So it's going to break, and I at that point is index 1, so we could just return I. And now there's one edge case where we have to, or like, I guess a set of edge cases, but like one special scenario we have to go through. And that's if the target is beyond the array. So for example, in this 7, this target would be outside of it. And with our pointers right here, I can only increase and j can only decrease. So the maximum value that we can return is going to be nums.length minus 1, whereas with this 7 we're returning 4, which is the nums.length, so it's going to be greater than that. So we're just going to look out for that. So if nums of nums.length is less than the target, length minus 1, then we're going to return nums.length. So let's see if it works. All right, great. Now let's submit it. All right, great. So that was search insert position.